Assalamualaikum warahmatullahi wabarakatuh. It is an honor to be presenter in this international conference on mathematics and learning research 2022. My name is Ade Elvera Chandrawati. I'm a student in Syekh Kuala University, Banda Aceh, Indonesia. Here, I will explain something related to the explanation of my research entitled Spatial Reasoning Skills of Year 5 Elementary School Student Through Realistic Mathematics Education. In this opportunity, I will explain about in the introduction, method, result and discussion, and conclusion. Spatial reasoning skill is required in mathematics learning activities. It is crucial to develop it at an early age so students can recognize their surrounding spatial environment for their future success in basic mathematics competencies. In reality, spatial ability is important to be possessed by students, but in fact, several studies reveal that spatial reasoning skills are getting less attention from teachers. Because many educational practices in schools today lack visual spatial reasoning skill output, which means that many spatially gifted students are not identified, supported, or developed. The effect can lead to neglecting students with good spatial skills. UTAL in 2013 found no significant difference in the effectiveness of spatial training across age groups under 13 years of age. Lori and Fatahudin in 2015 used the ELSA learning framework to design materials for the spatial reasoning intervention program. Ramful, Lowry, and Logan in 2017 designing a spatial reasoning instrument based on a curriculum standard in school. Atasoy and Osden in 2020 conduct learning coding through software to improve students' spatial reasoning skills. An alternative approach that can be used to develop students' visual spatial reasoning skills in the realistic mathematics or RME approach. This approach start from the real thing for student, emphasizing the process of thinking, discussing, and collaborating with peers so that they can figure it out for themselves and ultimately use mathematics to solve problems individually or in groups. From all aspects of the observation made to students through the RMA approach, each cycle look better. Students become more enthusiastic and show activeness in the learning process. Students look more interactive in groups when expressing their opinion. Based on the background described above, this study discussed student spatial reasoning skills, especially spatial visualization or reasoning in finding the block volume formula that is carried out in group discussion using a learning trajectory following basic competencies through the RME approach. Therefore, this study aims to examine the spatial reasoning skills of year 5 elementary schools students through RME. This study is quantitative descriptive. The researcher prepare mathematic learning tools in lesson plan or RPP and research instruments in the development of students' worksheet or LKPD as the references for students' activities in developing spatial reasoning skills. The subject in this study were students class 5-1 of Min 11 Banda Aceh, totaling 36 students. These 36 students were then grouped into six groups, each group consisting of 6 students. The instrument used is in group assignment arranged in the form of LKPD. The data obtained was used to analyze students' spatial reasoning skills. The assessment technique is adjusted to the basic competencies. The assessment criteria used are based on the minimum criteria of mastery learning because the data will also be used for assessment needs in the education unit. The KKM in the education unit is 75. The assessment technique is adjusted to the KD assessment by utilizing the following formula. Percentage is obtained score per maximum score for 100. The percentage result are then categorized based on the criteria followed. The KKM 75 interpreted in the following table. The score of the completion sheet were collected and analyzed to assess students' spatial reasoning skills in finding the block volume formula. Total score is group 1 69, group 2 81, group 3 81, group 4 75, group 5 69, and group 6 44. In activity 1, spatial reasoning skills can be seen from the number of blocks designed by each group. 3 groups got 6 blocks, and 1 group got 5 blocks, 1 group got 4 blocks, and 1 group only got 2 dimensions of blocks. Activity 2, 1 group drew 3 blocks of the 6-dimension blocks obtained. 2 groups drew 2 blocks, 1 group drew 2 blocks, 1 group drew 2 blocks, and 1 group drew 1 block. From the figure, only 1 group looked appropriate and the other groups did not fit. In activity 3, each group in problem 3 was categorized as very good. In activity 4, groups 1, 4 and 6 was categorized as good, and each group was categorized as very good. Conclusion: based on the result, it can be concluded that at the situation stage, there are three groups under the KKM in the needs tutoring category and three other groups in the ENAC category. At the model of stage, all groups scored above the KKM, with one group in the good category and five other groups in the very good category. At the model 4 and formal knowledge test, all groups score above the KKM in the very good category. However, students still need tutoring at the situation stage, namely in designing various dimension of blocks from many unit cubes so that students can find more block dimension that can be designed. Students also still need tutoring to be able to illustrate blocks to form figures correctly. Furthermore, it is hoped that this research can be continued for year 5 students and further expanded to year 4 and 6 elementary school students. In addition, it can also be developed through a study to build a democratic classroom through RME. That's all my presentation. I apologize for my mistake. Finally, I say wassalamualaikum warahmatullahi wabarakatuh.